Welcome to the Explainer. You ever see one of those incredible AI demos and then wonder why it never seems to work that well in the real world? Well, today we're going to dig into LangGraph. It's the architecture that's aiming to make AI agents not just smart, but, well, unbreakable.
Yeah, I mean, we've all seen them, right? These super impressive AI demos where everything just works. But then you get them into a real-world situation, something complex and messy, and they just get stuck or confused. Sometimes they just totally break. So what is going on there?
Well, the core problem is really in their design. You can think of it like this. Most simple AI apps are basically following a printed map in a world that desperately needs a live GPS. They're built on a one-way street, Go from step A to B to C. If they hit some unexpected roadblock, that's it. They can't turn around, they can't reevaluate, they can't find a new path. They're just stuck with that static plan.
All right, so let's get into Section 1, Beyond Simple AI Chains. This is about shifting from lines to loops. See, this whole limitation, this one-way street problem, it comes from a really common AI architecture. It's called a directed acyclic graph, or a DAG for short. And the key word there is acyclic. All that means is no cycles, no loops, no going back. It is fundamentally a one-way street.
And this slide just lays it out perfectly. On the left, you've got your simple chains, your DAGs. They follow a one-way path, they can't self-correct. They're fine for simple sequential tasks. But on the right, that's LangGraph's stateful graph. It's not a line, it's a dynamic web of possibilities. It allows for cycles and loops. It can reevaluate and try again. And that is what's absolutely essential for what we call agentic behavior.
And that quote right there really gets to the heart of it. Agentic behavior cannot be represented efficiently, if at all, by DAGs. Because look, a real agent doesn't just blindly follow instructions. It needs to think, then act, then observe the result, and, this is the crucial part, think again based on that new information. It's a loop. This reason and act cycle is a loop, and it's a pattern that those simple chains just can't handle. But LangGraph, it's literally engineered for exactly this.
Okay, Section 2, Thinking in Stateful Graphs. Let's look at the agent's cognitive architecture. So, how does LangGraph actually build this GPS for AI? Well, it's not magic, not at all. It's just some really clever engineering that's built on 3 core components. And together, they create this cognitive architecture for the agent.
First up, and honestly this is the most important part, is the state. The easiest way to think about this is like the agent's working memory or its short-term memory. It's a complete snapshot of everything that's relevant to the task right now. The conversation history, any data it's found, its current plan, it's all in there. Now what's really crucial is that the different steps in the process don't change the state directly. Instead, they just return updates, and that little detail keeps the whole process super predictable and traceable.
Okay, so you have the state. Next, you have nodes and edges. Nodes are the doers. They're the functions that perform actions, like calling out to an LLM or using a tool. The edges are the deciders. They're the pathways that connect all these actions and direct the flow of information. But the real game changer here, the secret sauce, is the conditional edge. You can think of it like a smart traffic cop. It's constantly looking at the agent's current state, its working memory, and then decides which node, which action, to send the process to next. It's dynamic.
And this is how it all comes together in that reason and act cycle we talked about. It's a loop. First, the agent thinks, using an LLM node to analyze the situation. Then that conditional edge, our traffic cop, it decides. It checks the LLM's output. Does the agent need more info? If the answer is yes, it routes the flow to an act node, which uses a tool to go get new information. That new info comes back, and the flow loops right back to the beginning, to the think node, so the agent can reevaluate with this new context. And it just keeps cycling through that loop, think, decide, act, loop, until the job is finally done.
All right, Section 3. Now we're getting into what makes these agents truly unbreakable, persistence. I mean, a flexible reasoning loop is a fantastic start, right? But what really makes an AI agent genuinely reliable enough for the real world, the answer is persistence. And this is where a feature called the checkpointer comes in. The absolute best analogy for this is an automatic save game system, like in a video game. After every single step in that reasoning loop we just talked about, LangGraph takes a complete snapshot of the agent's state, all of its memory, and saves it to a durable backend, like a reliable database.
Now this checkpointing system, it's not just a simple backup. It's so much more. It basically unlocks these superpowers that are essential for any serious production-grade application. So if the system crashes,
No problem. It just automatically recovers and resumes exactly where it left off. No progress lost. You can also time travel. You can literally rewind to any point in the agent's past to debug an issue or even explore a different path. And maybe coolest of all, it allows for a human in the loop. You can pause the agent, have a person inspect its state, make changes, and then just hit resume.
And this enables a really revolutionary design pattern: stateless hosting. This is the architectural masterstroke. Think about it. Because the agent's memory, its state, is always saved externally in a database, the agent's brain, the core logic, can be completely stateless. And this is a huge deal. It means the computation part can run on these cheap, scalable, ephemeral cloud services that can start and stop on a dime, all while the memory lives safely somewhere else. This separation of computation and memory, it is an absolute game changer for building reliable, cost-effective AI at scale. Okay, moving on to Section 4, how LangGraph compares. So with all this power, all this control, where does LangGraph actually fit in the broader ecosystem of AI frameworks that developers are using today?
The whole AI framework landscape is really about trade-offs. You've got LangChain, which is awesome for its simplicity and how fast you can get going. It's perfect for building a quick prototype or a pretty straightforward chatbot. LangGraph, on the other hand, trades some of that initial simplicity for a ton of control and reliability. And that's what you need for complex mission-critical systems, like, say, an autonomous financial analyst. And then, of course, you have other frameworks like CrewAI, which are focused on a totally different problem: how to get teams of different agents to collaborate.
And here's something that's a huge advantage for a lot of teams out there. LangGraph isn't just a Python thing. Nope, it has a first-class, fully supported SDK for both JavaScript and TypeScript. This just opens the door for that massive community of web and full-stack developers to build these kinds of robust agentic systems without having to manage a whole separate Python environment.
Okay, last section. Section 5, the future is stateful. Let's wrap this up and zoom out a little bit. What's the big picture takeaway here? What's the one thing you should really walk away with from all of this?
It's this. LangGraph really helps us move on from this idea of magical thinking, where we just write a clever prompt, send it off to an LLM, and kind of cross our fingers and hope for the best. LangGraph replaces that with sound engineering. It provides a real architectural framework to build, manage, and govern these complex AI processes so you get predictable and reliable behavior. So if you remember anything, remember these key takeaways. First, the big shift from straight lines to dynamic loops. Second, that state is everything, that centralized state management is the key to memory and reasoning. Third, that checkpoints are your safety net, giving you fault tolerance, time travel, and human oversight. And finally, it's about gaining control over the chaos, putting architectural guardrails on AI's probabilistic nature to make it reliable. So I'll leave you with this question to think about. If an AI agent's intelligence is its engine, then isn't its ability to remember, to recover, and to be governed its chassis? You can have the most powerful engine in the world, but without a solid, reliable chassis, you're not going anywhere safely. LangGraph is that chassis, and it's what's going to let us build AI that doesn't just work in a lab, but can finally, truly be trusted out in the real world.